Okay, it looks like not too many people today, but let's get going. Since it's 5 after already. Anyone want to share progress or what they did last week? No, Alex, can't hear you. No, can't hear you yet. Very faint now, but
Hello?
yep, we can hear you now.
Cool. So maybe I can just briefly update my progress. Wait, let me rename my account name. Wait, I got some technical issue. Wait, I think I need to share later. My laptop gets stuck. Probably I need to restart it.
Oh, okay. While you do that, let me just mention or share two things I was able to get done. I was not able to do too much this week. I was trying a longer term, slightly different approach. But meanwhile, I did try a couple of things. I'm trying a different fast AI approach in the sound domain itself, but I haven't got it all working yet. But meanwhile, I tried, as we discussed last week, Alex, you had mentioned most of the sound of the species is about, except for one or two exceptions, it's about 7 seconds. So I kind of increased. If you recall, I was doing variations from anywhere from 10 I tried 10, 5, and 4. And obviously my 5-second had given the best result as far that I saw. And based on
how many gain do you get?
Sorry?
How many performance gain do you get when you change to 5 seconds?
10 to 5, I think it was quite substantial. Let me see. Mm, 10 seconds to 5 seconds, almost like 0.01 or something like that. Let me see where my, yeah, maybe even 0.02. I think this was my best 10 seconds, and that's 0.86. And my best 10 seconds, and these are public scores, private scores, maybe even slightly higher, but it went from 863 to 5 seconds is 887. So that's 86 to 88, so 0.0, or even 863 to 887, so which is 0.02 something.
Okay.
0.024 or something.
That's quite significant.
That much.
Good to know that. Actually, I didn't use 5 seconds. I think I based on that, I got a trial 5 seconds. Right now, I'm using 8 seconds.
And then, but based on what we discussed, I tried 6, and as you saw, my thing was 883. I got like another slight boost. You can see 0.885 here, as opposed to my best 5 seconds score was like 883, I think, and this is 885. So it did give me the 6 seconds as opposed to 5 seconds. Again, gave me a little. I mean, not as much as going from 10 to 5, but it did give me a boost. And interestingly, and it kind of confirms what we discussed last week, I had already run this 4 second last week, and we saw a drop. I saw a drop from 5 seconds to 4 seconds. It's kind of, the explanation is consistent, right? Because as I drop the chops, then there aren't as many species that, there are more species that kind of escape, if you will, proper recognition when you do a 4. So when I increased it to 6, then I saw a slight increase. Now, the other thing, interestingly, I tried based on what Alex, you had commented, which is that when you did, with your approach, when you did the NML to 256, you saw, in your case, I think maybe even a 0.02 or something increase in the score. That was interesting. So I thought, and I had not tried all of my results so far. I've always been with 128 nmls. So I thought, okay, let me give that a shot. And that 128 nml was based on the blog post that Arto and I had found, and Arto had pointed to, which had done, and the person who posted that blog post had done a whole variety of studies using ResNet, DenseNet on what parameters gave him the best results for sound related classification using DenseNets, ResNets, maybe EfficientNet. I don't remember whether he did EfficientNet, but I do remember DenseNet and ResNets and ResNets, all three he had used. And he had said, oh, 128 gave him the best results. So I kind of didn't explore too much. Based on what you had said, though, I tried, once I settled on, my 6 second obviously were the best. So I took the 6 seconds, all other settings the same, and I increased the number of mels. I doubled it from 128 to 256. I actually saw the score go down. You see the 0.00 versus 0.80 versus 0.885. Now, not much of a difference, but still a slightly lower score. The one other thing I looked, I was aware of when I did it, and I did it deliberately, as I mentioned before, my image size of the spectrogram I resize in my notebook to be 224 by 400. Now,
Also,
because
before you change, so the thing you're comparing against is you have a resized image, right? So you do a
correct.
resize first, and then you increase the end mail, or you reverse the order.
Actually, it is I do the NMLs and then I resize.
I see. Because in my case, I didn't do any resizing.
Right. So I wanted to kind of make sure that my, resizing wasn't the cost, if you will, of this drop. And so I kind of changed the resizing to be now, as I mentioned, my base is 224 by 400. So as long as, and what I thought was, as long as I provided 256 pixels on the Y, which I'm not in my base case because it's 224 by 400, the x-axis shouldn't really matter, and the y-axis is the one that I'm kind of impacting by my number of nmels. So because that's the frequency related log frequency, but that's the y-axis that matters. So I did change or increase the image size to 256 instead of 224. And sure enough, you can see that it got closer to what I was saying. So it's like now the difference is only 0.002 instead of 0.04 something. So it does seem to get back, but at the same time, the point is, at least for me with my setup, and this is, consistent with many other computations they've done, and a lot of it seems empirical. The same benefit that somebody else sees with their approach is not exactly the same that necessarily that others see. So that's what I saw, that I got back to where I was pretty much, but I didn't see a boost because of the increase in number of nmels. Now, obviously, the other thing, and I didn't play with that because I need to get into the details. The number of, obviously, I have a number for my FFT windows and then my hop and all of that. And I obviously didn't change any of it, and I only changed the nmels. So it's entirely possible that if I played around with my FFT, my nmels, my FFT window, my hop window, and my nmels, then maybe I'll see a difference in the score. But at least just doubling the nmels, keeping everything else the same, and even allowing the image to be whatever size it needs to be on the Y dimension to capture the increased number of nmels, didn't give me a boost in the score, or at least not as much as you saw, Alex.
What is your FFT
So
and
those were the
hop
two
size
experiments.
currently?
This one currently it's 4K on FFT and 512 on the hop size. 4096, 512.
Oh, okay. Then your FFT is quite a lot. If you do 4K, because the FFT, from my understanding, FFT control the resolution on your frequency axis. Right now I'm using roughly 2K.
Yeah, that's what I had. Again, if you saw way back, I had, this high FFT moniker tells me that I changed it to 4K, and that did give me a little bit of a boost. I forget now exactly what. I was playing again here with the resizing, but I have to go back and look at my
Is it significant
to see. Yeah, I did. increase my score somewhat. It was significant enough that I chose to stick with it. I'm trying to look back at the, I switched to 5 seconds. 5 seconds gave me a boost, and then 5 seconds with amplitude gave me a little bit more from 0.87 to 0.884. Oh, here you see 0.884 to 887. You see this difference? The only difference between these two is a high FFT. So when I switched from 5 second window 2K FFT with hop of 512 to 4K FFT hop of 512, I went from 884 to 887. Everything else.
It kind of makes sense to me. Like,
it
kind of makes sense to me. It's essentially equivalent to having a higher resolution of image in the CV from a CV perspective. So if you have more information, likely the model learns better. And it just comes to my mind that I do think the NFFT parameters correlate with the NML parameters, because by the time I look at the source code from Torch Audio, they will firstly do the spectrogram transformation. So in the frequency axis, you'll be determined by the number of FFT. And then after that, you do the mel scale transformation. So if your first step have higher resolution, then having a high resolution and the second step will help. So I do think that this kind of parameter are correlate. So if in another way around, if your first step have low resolution and your second step have high resolution, it may not help much.
Right. So
just some of my
IFFT,
it's just some of my thought, right?
Sorry.
Go ahead. Sorry. I just say it's just some of the thought. I haven't validated yet. Yeah, you can go ahead. Sorry for interrupt.
Yeah. No, that's okay. So that's where I, obviously saw a boost from 884 to 887 when I changed SFT stuff. But that's kind of where I was at.
So what is your best score so far?
It is 88. No, sorry. On the private score, I believe it's 89 something. With corresponding to my 6 second public 83. But I think this one is the one that I had the best score on. And you see, I made the 256 by 400 as opposed to 224 by 400, and that didn't. This was when I was playing with the NMLs, but my best score is 89 something. I forget, but best public is 0.883. Sorry,
it's quite good.
0.885. So that's, I was trying to push it past 0.9, but again, this is, I did get, past 0.9. But I think I have one or two ideas that would just get me past 0.9 by just doing ensembling of, or what we were discussing, I think a couple of meetings back, the not just average ensembling, but this I forget what the term is, but the not ensembling based on average, but ensembling based on the
rank,
position, right? Or the leaded rank. Yeah. rank averaging. So that is one idea. And then I also did not apply what you had pointed out, and some others in the competition have also pointed out, which is, if you adjust some scores based on your leaderboard probing, then that would also increase it. But, I wanted to kind of get a base model that gives me a best score, if you will, and then apply those other tricks on top of it. Of course, I tried some of those tricks early on to make sure they work, and they did. But I haven't, so my 0.89 that I'm telling you is based on not ensembling, just basically running the thing and submitting. I think it will go up a little bit if you do the rank averaging, and also I did see a better result when I averaged, for example, 6 seconds with, and I had done it before. I didn't do it with 6 seconds, but when I averaged 5 seconds with 10 seconds or 5 seconds with 4 seconds, then my score did go up. Not by a whole lot, but by a tiny bit. So that's where I said, again, I'm kind of close to 0.9, but I'm not getting much better. So I'm trying something slightly different. They couldn't get it to work this week, but I think I'll have it working by next week on, using FastAI. One thing I did want to ask, maybe your, if anybody else, if Yuri has also done it, or is generating data on Kaggle and then kind of storing it on Kaggle as data sets, because that's something I'd like to do, is just like process the sound at a, because resampling, the base sampling rate is 48,800, I think, or 48,000. And then if I wanted to sample at 32,000, because I think the max frequency is only 16K, and I did do that, but I, did it on the fly, meaning I stored it all in memory. But what I want to do is generate those files at a different sampling rate, like 32,000, store it as a data set, and then use that data set in a notebook. And I was just wondering whether either of you have done that, and if so, is there an easy way to do it, or because writing it as output doesn't save it. If you're just running interactively, you need to kind of run it in the save and commit method. And
yeah, saving data set to Kaggle is pretty easy. I think it's pretty friendly. They provide you pretty good interface for you to do that. So what you need to do is you prepare a notebook, and then you prepare the notebook to write those files to the notebook session. And then you just click save and commit, just like what you did when you train a model. And then you check out the notebook again and go to output. So you will see all the files you want are written. And then what you do is you just import the notebook output into your training notebook. So you can kind of.
So it's just a matter of writing, save and commit, and then I've done importing of notebooks where other people had. So it's you can do the same. Okay, so that's simple enough.
Yeah. So but just wondering why you want to do the resampling?
Primarily, at what I've seen is if I'm doing it at 48K, which is the native rate at which the audio file has been sampled, then it's very quick, and it does it because there's no resampling involved. It's already sampled at that rate at 48K. But if I wanted to do it at 32, because the maximum frequency of any species is only like 15 something, 15xxx. So I was thinking that if I have a sampling rate of 32K, then that's good enough, because 32K by 2 is still 16K. So based on the Nyquist theorem, blah, 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 I have all of the species sound frequencies covered at 32. By taking 48, I'm actually not benefiting much because or in fact, I leave a bunch of frequencies on the table because I'm not focusing on the range which matters. On the low end, there's not much gap. It's only about 20 hertz because some of the species go down, I believe, up to 20. But if on the upper side, the max is 15 something. So it's definitely less than 16. So if I resample at 32, then I should be good enough. But 32 is not 48, 32K. It's not 48K. So what happens is, it takes a long time to run and resample all of the data. And if I don't want to waste as much of my GPU time or CPU time doing that, then it's a lot easier if I do a resampling once at 32, store it away, and then after that, I only read those resampled files in the sound domain, even if I wanted to convert them into MEL spectrograms later.
Do you find it a bottleneck, like it compute really slow by the time you do resampling? Because I haven't tried resampling yet.
Yeah, I did, and I mean it worked. In fact, I think I show.
Because what I found is the bottleneck is actually the spectrogram transformation.
Yeah, so I have, see here, SR30, well, I'm not actually sharing. Let me share my screen just to point to. So I did do one run where I tried all the other settings the same, just resampling 32K with a 5-second stuff. My score didn't go up. It actually kind of went down compared to what I'd seen with 48K. So I didn't pursue it. But as I mentioned, now I want to stay, and this is somewhat related to, I think you had mentioned it previously, that if you apply augmentations and or in the sound domain, then it's, so one thing I wanted to try was resample, apply the augmentations in the sound domain, then convert to MEL spectrogram. But for that, if I need to resample, then I'd rather resample it once, store it away, and read it back rather than keep resampling on the fly. By keep resampling, I mean, rather than, because I did see this particular run take me, I would say it was 1.5 to 2 times slower.
How do you do a transform right now? Do you do a transform by a helper function, or you do it in the torch audio low in?
In Librosa.
Librosa. Also, you specify the sample rate, right?
Yes. But, it's just a default sample rate, which is 48.
Oh, because I assume it doesn't affect the performance if you specify the sample rate in the browser, but in fact it's not. Okay.
Yeah, he just uses the default sample rate, which happens to be matching what the sample rate.
So what Librosa is doing underneath the hood is it read with the original sample rate first, and then resample it to your specified sample rate.
No, it's actually, if you specify the sample rate, then it's different than, Librosa uses the default of 48K.
Let me
so if you, 48,800 or 48, I forget, but 48K. And this wave file is also sampled at 48K. So, if you say SI equals none, it uses the default sample rate. which matches the sample rate of the wave file in this case. So everything works and it works really quick. But if you specify SR, instead of saying SR none, you say SR 32,000, then it resamples the original samples, and that takes a while.
Okay.
So that took
to speed up, you can,
at least.
Yeah, I just want to say like, yeah, you can easily, I think you can fix that by just pre-compute and save it to Kaggle notebook.
Yeah, yeah. In fact, actually, Steve, if I recall correctly, was doing that so he could have those files in Colab. But again, I'm not running out of computing Kaggle, so I'm sticking to Kaggle for this competition, although I've done.
How many times speed up do you find?
Sorry?
How many times speed up do you find if you do pre-computing?
I was saying in my case, it's more like a slowdown when I went to resampling, and I thought I saw, and I didn't exactly time it, was more like observation of how much time it took to run. I thought I saw something like somewhere between 50 to 100% overall. By that I meant, like if my normal 48K run took an hour to run, this thing took like somewhere between 90 to 2 hours, 90 minutes to 2 hours. That's just ballpark estimate. I didn't time it. It just took a lot longer for it to run.
I see.
So
I think one benefit is also, oh, sorry. Go ahead.
Yeah, because also, go ahead, Yuri.
Oh, yes, sir. So the expectation is that if you go to with 32K sampling rate, that your basically data will be twice as small, or it will be zoomed in on the important stuff.
Yeah, it's more the latter, that basically because you're sampling at 32K, the max frequency you can track is only up to 16K. But that's fine because the max frequency that we have that we are interested in is only 15 point something K. So it's more of the fact that, then my y-axis is better tuned to the sound frequencies of interest rather than it's simple matter of not wasting pixels on frequencies that you don't care about.
And also, I think you mentioned it a few times, but I forgot like what you ended up doing right now. So all your augmentations are done in advance. So you just like, or do you do it? You don't do it like in line, right? Your augmentations are pre-computed.
No, I do inline, but I do it on the image. See, there are two things you can do.
The image. Got it.
Augment. Yeah.
And that's what there's a way you can augment an image and do it like not like an image, but like as a sound. Like, is there a way to do
before
it
converting,
so it doesn't violate like rules of the spectrogram?
Yeah, or as Alex was saying, more knobs potentially. I think he was commenting on last week and stuff that you could potentially do more things in the audio domain itself and then convert to a MEL spectrogram. And that's kind of what I wanted to try. I had tried it in one instance before, but I'm not sure whether I, got it working properly when I did it before. And I just wanted to kind of try that approach of making the augmentations in the sound domain and then convert, first of all, sampling at this resample rates. I'm zoomed into the frequency of interest, apply augmentations in the sound domain, then take it to the MEL spectrogram, may or may not apply additional augmentation in the spectrogram or image domain, and then check. And I kind of wanted to take that approach to see whether I can cross the 0.90 barrier, which I haven't been able to on a base model. If I can get there with a base model, then I can apply these additional tricks of ensembling and rank averaging, and and also adjusting for the frequency of the species. Those kinds of things which are on top, I can kind of those I consider kind of cherry on top after I get a better base model which gets me past the 0.90, then apply those to see how far down towards 0.98 I can get.
Okay, thanks.
I would think your speed up will technically work, but I just wonder, I guess there's a better way to do it, because at the end you focus on the resolution of the frequency in your spectrogram, right? And by the time you do the spectrogram transformation, you can specify the maximum frequency that you want to take in account. So even though your audio have a very high sample rate, you can set this parameter to kind of truncate the end spectrogram that you get.
Yeah, no, you're right, because anytime you generate the MEL spectrogram, you always also specify F min, F max. So you may be right that, getting the or changing the sampling rate may not matter, which is kind of what I saw, if you will, even in my, that's why I showed you that I did try previously with resampling 32K. That's how I found out that it was slowing down a whole lot when I did that. But again, at this point, I was just trying, and maybe it won't yield as much of a benefit. We'll see. But in the process, okay, I just wanted to, if I can resample and store it away, then I can use those for multiple purposes. I need not necessarily apply. I can just use those to do the conversion to MEL spectrogram, and then follow my current approach as well. So.
Yeah, it makes sense. So, by the way, why do you want to try out the fast AI approach?
Some of it is just simplicity, and some of it I'm more familiar with fast AI. So I have tried that. In this case, I just would like to try different things. In fact, originally, way back when I started, I kind of did 2 or 3 based on the notebooks that are available. I did something with fast AI and fast audio, then torch audio, and so I was thinking that maybe it's simpler if I go that route.
I see. Because my feeling is that if you want to do a transition to fast AI, you're probably gonna spend 1 to 2 weeks or 3 weeks on understand the whole pipeline and even debugging the whole pipeline. Because my feeling, by the way I build my pipeline with fast AI, what I found is that it has a lot of defaults, and yeah, I don't understand what kind of default is silently applied on that on my own pipeline. Yeah. And also some pipeline actually fail to apply on my item, and I didn't know about that. And also actually it has some bug throughout the way. So for that, I actually recommend you install the latest version of Fast AI and Fast Audio, because it includes some of the fix. And so some bug that I encounter is that, for example, some normalization steps are missed out in the validation set. So I find out while the training is performing well, the validation performance is very poor, something like that. So if you really want to do a transition to that, I would expect at least in the first few iterations, 1 to 2 weeks, you will have a way lower LB score than what you have right now.
Yeah. No, that's possible because I tune the current method with so many hyperparameters and playing with variety of things that it's about really good, which is why it's gotten close to 0.90. So I do expect, but again, just so you know, I'm familiar with fast AI and have had multiple, in fact, had a whole session, a series of similar study groups that I went through, that I was the host of for fast AI 2 walkthrough of the code and stuff like that. So I'm much more familiar with fast AI than the average person, but at the same time, I totally agree with you. Even now, even though I've seen it, I've forgotten much of it, and there's a lot of knobs. There are a lot of knobs, like you mentioned, which are kind of, for lack of a better word, auto-configured or defaulted to in fast AI, and it's always a challenge to debug and dive through the code to figure out where it is getting set and what it is getting set to, which tends to take a lot of time when something doesn't quite result in what you expect. But we'll see.
I would say that
works out.
Yeah, to me, because I take a chance to dive into fast AI framework throughout these competitions. So my feeling is that the learning curve is pretty stiff, in the sense that at the beginning you need to read a lot of source code to see what is going on underneath the hood. But I would say the upshot is that, like, once I understand the pipeline, I can easily modularize or customize it, and also very easily to utilize its helper callbacks and some of the state-of-the-art technique that's already pre-built in the library. Just some of the feeling.
Yeah, especially the learning rate tweaking and the fine. You can quickly change losses, but at the same time, it's tricky because some of the base losses, like the cross entropy and other things, as in Jeremy, has flattened those losses. So you have to kind of be aware of the shape of those things if you're just using them as is. But like you say, with the callback capabilities, specifically, I like the fact that, some of the learning rate modulations that it provides, and then it also allows you to code a lot of these things. When I say these things, the augmentations can be coded as transformation, quickly create a pipeline, those kinds of things are handy things to tweak once you get the pipeline working. But yeah, you still have to be aware of what's going on underneath, and that sometimes trips you up. But I'm still thinking of sticking with Librosa. I'm not very familiar with the fast audio thing yet. So, but again, fast audio pretty much, or even torch audio, they all seem to do similar things, and ultimately, so far, all I've seen is there's not that much different between using any of these libraries, fast audio, torch audio, or Librosa, because all of them just basically take a bunch of parameters and convert them to what we need.
Yeah. I from what I saw, fast audio mainly use torch audio to load in the tensor and do the spectrogram transformation. And it is using the browser to do the visualization.
Yeah, we can see your screen now.
So I think I can quickly go through my part. So essentially, this week, mainly what I do is, so first change is I try to use a ML 256. what I found is that the performance gain is quite a lot. So I'm comparing against my baseline. So the baseline is, so this is my baseline, row 32. So you see the public LB. I don't see that. I won't look at the private LB. In first, in the competition, I won't know private LB in advance. That's the first thing. Another thing is that I do see a gap between the public LB and private LB. So I mainly look at the public LB. So you see a score is something like 0.758. And if I double the NML, I can get something like 6% increase. So you see increase from 0.75 to 0.81, which is quite a lot.
Okay.
By that time, I'm quite doubtful about this result. So what I do is I try to rerun it again. So you see, in the following two experiments, I just used exactly the same configuration because in my experiment, I didn't control any random seed. So even though I use the same configuration and I rerun that, I will get different results. So I just try to do that. And what I get is the score vary a lot. Even though they are strictly higher than my baseline, but you see the difference is a lot. So you can see the local LB does not matter much, but the public LB has a pretty big difference. Roughly 3 to 6%, 3 to 6 point, I mean 0.03 to 0.06. So it drives me to think like in this competition, the randomness really play a role in the public LB. I don't know whether it's because of the NML or the dataset itself. I guess it's about the test set because the test set only have about 400 data points, as I remember, because the test set have in total 2K data point, and it only use 20% as a public LB. So I would say in such a small sample size, it's easy to have such a high variance. And it's also, so in this case, if I know this, it's really hard to me to draw a conclusion based on one single number, you know. Whenever I do a small configuration change and I notice one score, it probably is a high variance observation. Probably I need to rerun it again to validate the idea. So moving forward, I further increase the ML to 320. This time I only run it once. It doesn't seem to have a much difference as you see here. So at the end, I just stick to 256. And then after that, what I do is I try to. So firstly, I want to change the loss function.
What is the hop for you? What's the hop length for you?
As far as I recall, it's 512.
512. Okay. Yeah, because the other thing to try based on what at least my results, and you may again not see the same or it might even go down, is see whether if your NFFT were to be increased, keeping everything else the same, whether you get different results, better results or not.
Yeah, I mean the configuration on the Mel spectrogram transformation, the hop size. I guess the hop size should be as low as possible. One thing I can try is I change the NFFT and the NML together. So let me check what is the default setting. Wait. Now spectrogram. Does it have it? I don't think I can easily find it. Okay, let me see. Yeah, I'm using a default. Does it have default? Window size of 12. Yeah, so I think it's the half of the NFFT. So the NFT I used is,
Yeah, if that's half, then it will be 1K versus 512. But I
am I
thought you had
using
mentioned
1K?
previously or something about 512.
Oh, 2K. So the hop size is 1K. Yeah, should be. So moving forward, so what I do is I try to change the loss function. Instead of using the binary cross entropy, I use the mask binary cross entropy. So it's just a simple change. Essentially, one observation is one label, right? So what I do is by the time I feed it into the binary cross entropy loss function, I mask out the loss for the other cast. So I do the same. Yeah. So for this row I highlight, I only apply this on the true positive data. So you see that if I do this, I only change the loss function, right? The score will deteriorate a lot. And the reason is
So
because
what is the masking you're doing? Sorry, I didn't. Can you? So
because
would you?
when you feed the input to the model, right? So what the model do is they independently predict the probability of each class. And then you feed this and then you feed this 24 a factor of 24 size factor. Each one is a probability into a binary cross entropy function, right? So by the time you do the loss function, by the time you evaluate the loss, you will take the average over 24 class. So that's what the naive vanilla binary cross entropy loss does. So I do a minor calibration on that. What I do is instead of taking an average over 24 class, I only consider one class because each observation only have one label. So I only consider the loss with respect to the label that we are targeting. So let's say the observation only have a label of class 1, then I'll focus on the loss for the class 1 only. The rest of them will be marked as 0.
I see.
You know what I mean?
So you are using binary cross entropy, but masking everything except the correct label. Why wouldn't you switch to just cross entropy then, or what am I? I guess that's the equivalent in a way to doing cross entropy. Or am I missing something?
It is different. It is different in the sense that if you do so let's take an example. You only have one observation, right? The ground truth class is class 1. If you feed it to binary cross entropy, you will inform the model that you want the model to predict high probability towards class 1, and at the same time predict low probability on the rest of the class. Because essentially you are informing the model class 1 is the only label exists in this clip. But I would say this setting is not right in a problem in the sense that in many cases, the clip can coexist a lot of species in the same period of time. So if we instruct the model to learn in this way, it is very possible to have a lot of false negative. It means that it will fail to identify the rest of the species. So what I want to do is, I think a more correct way to set the model is that I only know the existence of class 1, but I don't know the existence of the rest of the class. They may or may not exist. So I should not back propagate the model. So I should not inform anything about the rest of the class to the model. So I think that would be the rationale why I use the masking loss. And by the time I read out the winning solution, this masking loss occur a lot of time. So I think it has some ground. That's the idea.
All right. Okay. But just FYI, my thing that I'm doing is actually just cross entropy. So it's does. So I'm curious to do some EDA to see how many overlapping or multiple species exist in any, for me, I guess, 6-second window. But right now I'm just doing cross entropy. So
it's a softmax, right?
So it's just a single. So it's just a single. So it focused just on a single species. So it has the problem that you are saying it does, which is it will not recognize any other species that exists in a particular.
Wait, do you pass through? So wait,
slice.
do you pass through it a sigmoid layer to each class, or you pass through a softmax across all the class?
It's neither, right? It's just one class on any given slice. So it's softmax in a single class. So it's
I know. So
just,
in my case, I also have one label for each observation, but I will pass it through a binary cross entropy. So it means that each class will independently pass through a sigmoid layer. But do you mean is it the same in your case?
No, it is softmax of because I'm not thinking about, since I've studied the code, that part of the code recently, but it's mainly, I think, just recognizing a single the species that has the max.
I see. So it should be, I guess, it's softmax.
Yeah.
Okay. So moving forward, so you see, I'll go ahead. So you see the score is very poor, right? I noticed the reason is because the model keep predicting 1. I think it's kind of like makes sense because I only have positive example in my data set. And if I mask out the rest of the class, so you end up every label I feed to the model are positive class. So in this case, the model are subject to learning very poorly like this. So what I essentially do is the next step, I combine the false positive data together to train the model. So in this case, I will have both positive and negative class to train, right? So after doing this, I get back to the normal score, 0.79, close to 0.8. But one thing we have found is that the validation, the local CV is significantly lower. It's only 0.67. But if I feed it to the public LD, it does so much better. So it prompted me to think, like, in this case, the local CV is not really correlate with the public LB. Another thing is that I think if I do in this way, I think what this model learned is quite different from the baseline model that I have. I mean, the model I keep developed in the past, for example, the baseline one, because based on this metric. So what I guess is that the model learns something that can generalize, but it has something failed to learn, which is very specific to the training data set. Or it is specifically good at detecting false negative or false positive, but have some kind of more substantial weaknesses. So just some of my guess.
Yeah, but also, isn't it possible that, because I've seen a lot of commentary, but at the same time, not a very good explanation of precisely the problem that you're seeing, which is that nobody in this competition that I've seen, just reading through the, not the best result, but kind of the rest of the postings, nobody has been able to get the local CV to correlate with the leaderboard results. They always see, I'm yet to see anybody say, yeah, I have a very good CV methodology that yields me good correlation between my CV results and my leaderboard results. Almost everybody that I've seen has posted in this competition, CV results don't match. And different people have come up with different explanations as to why, but nobody has a kind of solid, here is all the experiments I ran, here's why I conclude this is why it's different. I mean, people have conjectured why, but just, what you're seeing here, many people have seen, and at least I haven't seen any explanations for that I kind of totally accept or can completely buy into. It's been generally, here are my guesses as to why this is happening.
My thought is, I don't know what is the way to make it perfectly correlate, but I believe they should have some way to mitigate such kind of like mismatch, because if I imagine if I am in a competition, if I have some pattern like this, it's very hard for me to do decision, because in the case where I do a lot of experiment, I don't have any quota to do a submission. I need to totally rely on the local CV.
Local web.
But if I,
yep, no, I agree.
So if I have a validation scheme like this, and I come across this local CV, in this case, I could have totally abandoned the masking and this experiment run. So I could have totally abandoned this idea based on this very poor local CV. So I would say this problem is serious, and it doesn't seem like to have a very perfect solution to it yet, but I would say it's worth to mitigate it because of this kind of result. Like I think in this case, we look at we try to look it backward, because we kind of know or actually if we are in the competition, there's a way we can load this as well by simply doing a submission. But I would say, like,
right.
if we have something like this, it's really hard for us to do large scale experiment, and very hard for us to
I agree, but
decision.
what I'm saying, I totally agree the importance of having a valid CV to make decisions based on that, what you're highlighting. But what I'm saying is all the reading of the various posts that I've seen says that in this competition, the only way people were able to decide or essentially solve the problem that you're talking about, which is like, okay, what should I submit? In this competition, I think from all my reading, what I'm saying is, unfortunately, it seems like people just kept saying, I just submitted, and that's the only way I could figure out, because I kept bumping my head. There are potential explanations that people have offered. I think one guy came up with like 3 different things. And I saw a couple of other posts explaining, at least from their point of view, why the local CV was not tracking. But I'm just saying, so I'm not disagreeing with the problem and the issue importance of addressing it. I'm just saying I didn't see anything in the post that said, here, I have a solution, and here are the reasons it's different, and I have addressed it, and here is how I addressed it. Most of them just said, I gave up on it, and yes, it's a problem, and the only way we figured out was submitting it to the leaderboard, and that's what eventually told us what it was, whether it was good or bad, which doesn't obviously address the problem.
I think it kind of extract the problem if you are not doing a lot of experiment, and and the per day submission limit can pretty much satisfy your need. But to me, one solution in my head is to make the validation scheme, the validation scheme more, how to say, try to imitate the way I do the validation in the public LB, because in the public LB, I don't know the location of the subclip. It doesn't have the info profile to me. So if I want to have a more realistic local CV, what I can do is in the validation set, I need to scan through the whole clip and do the prediction based on the whole clip. So in this way, I try to imitate the submission process.
Yeah, so the test, you're trying to get the CV data to more closely match the test data that you will see when you do submission.
I do see some discussion thread mention about that. And they claim it could close the gap. I'm not sure yet. But I think based on this, I won't have much time to implement this yet, because I think it's a bit hard to integrate this idea into Fast AI. Because the pipeline, if I do this, the pipeline in validation set will look wildly different from what I do in the training set. I need to take some time to see how I can do the change in the Fast AI framework.
Yeah, that's an interesting problem, because I think it kind of, most of it assumes that your validation is identical to your training, right? So to split that and do it completely differently would be
I believe there's a way to separate out the transformation pipeline between training set and validation set. I think Fast AI offer this flexibility, but apart from that, there's another subtlety here. Is that because originally in the so the normal Fast AI framework assume that one observation will only have one tensor, right? But if we do a validation scheme like this, we expect one observation actually have a lot of tensor, because you will apply your prediction over different windows of this whole clip. So I'm just wondering how I can customize in this way, like essentially one observation maps to multiple tensor, and at the end we need to map it back to one single prediction, something like this. And also how to compute the validation score, how to compute the metric and attach it to the data frame table, something like this. Like I can foresee a lot of subtlety I need to address. So I think it won't be on my top list. It's something important if I was in a competition. Yeah. So what I noticed is there's a huge gap between local CV and LB, right? So what I do is I try to repeat the experiment again, try to run it 2 more times, and I would say the same trend holds. But at the last run, you see the local CV push up quite a bit, even though it's quite have a huge difference with public LB. And in this case, actually, is performing quite well in this case. 0.83. I think in this case, the best baseline I ever encountered. I tried, of course, I can do some post-processing on it to boost up the score, but right now I only look at the public LB score simply based on the model without any pre-process or post-process. So in this case, I'm just wondering why there's such a huge variance. One source is the test set. It has a small test set, so that's why it's a huge variance. Another is that I'm wondering whether it has something to do with the best model, the criteria that I save the best model, because right now I'm using validation loss as a criteria to save the best model. But if I do so, I notice that it will save point it will save point the best model at the early stage. So let's say I have 30 epoch. It find out the best model at 21st epoch or at the 18th epoch. So it means that the model trained in the later stage does not really improve the validation loss. But what I found is that there is a disagreement between the local CV and the between the validation loss and the validation CV. Wait and bounce and see. So what I see is that in this case, while the validation loss get worse, the validation LW rep actually improves. Wait me a second, let me find out some related work of this. Yeah, so I think this graph can show the case. So in this case, I say the best model is found in the 17th epoch. Okay, I think in this case better. At least you save at the later stage, 7th epoch. But you see that in some case, the local LW web increased, but actually the local loss also increased. So in this, you result in a better local LW web, but a worse local loss. Also some example. Okay, I see this here. So you see, blue is the training loss, orange is the validation loss, red is the validation LW rep. So you see, at the later stage, the validation loss actually fluctuate a lot. In most cases, increase. But you have actually your validation LW rep is actually increasing. So what I'm trying to run right now is essentially, I mean, still running. Instead of monitor the validation loss, I monitor the LW rep. So if I monitor LW rep, there's a high likelihood I can checkpoint the model in the later stage because it's a high chance I can get a better validation LW rep in the later stage. So I would like to see whether it makes such a difference. So that's the thing ongoing now. I mentioned the pseudo labeling last week, but I think in this week I don't have time to do that yet. Because beforehand I want to train a pretty solid model first. And once I have a solid model, I can get more trust on the pseudo label that it generates. And another thing is that by the time I do all this bunch of experiments, I actually run out of GPU limit. So I don't have any extra limit to generate the pseudo label. And then one more thing is on the meantime, I try to prepare another pipeline to speed up the whole training pipeline. To speed up the whole training, essentially, I want to pre-compute the audio spectrogram and then load them on the fly. So essentially, just the same thing you did. But instead of speeding up by catching the resample audio, I just catch the mail spectrogram. Where's the wait? I think this one. Yeah, what I found is that the speed up I can actually is a lot. So let me see if I can get some stat. From what I recall, if I can catch this kind of mass spectrochem, I can speed up by 10 times.
By the way,
So
just so you know, I think, and I'll see whether I can post the link. I think somebody has already stored the data sets of MEL spectrograms. Now, what I don't recall is whether he did it at multiple frequencies. I think he did. So, you know, you may even be able to just import his data set if
I would
that's
prefer
all
my
you're
own.
doing, but I don't know.
Yeah, I would prefer my own because I want to have more transparency on the configuration that I use to generate this spectrogram. And
Yeah,
also
that
one more important
is
thing.
different.
One more important thing is I may do more customization on that. So which means that this kind of cache will be expanding. And also because in the Fast AI, especially in Fast AI 2, they introduce a lot of subclass. So right now, the MEL spectrochem will have his own subclass, and it will also have its own metadata. So what I want to do is by the time I cache this subclass together with its metadata. But if I use others data sets, I think they were using the vanilla PyTorch tensor class. So if I use them, the consequence is that I can't enjoy the show function that I can get here, because in order to make the show function, you see the show function, I think, show method in a Fast AI, in order to make it work, I need to define a semantic subclass for the tensor. So yeah, so based on that, I will generate my own. It doesn't take long to generate my own. Oh, one more thing is that so if I do this kind of caching, I will sacrifice the augmentation that I do in the audio space. So to remedy, I can either give up to remedy that, just let it go. Or if I really want to have some augmentation in the audio space, right? What I can do is, by the time I generate the cache, I can generate multiple versions of that. So which means that for each run, I generate different, I apply different augmentation and then save it in the disk. In doing so, I need to have some prefix in the observation ID and suffix on the augmentation that I do. So this is some example of the customization I want to do in the dataset. So that's why I want to keep it on my own. But I think the speed up that I gain is really a lot. So I think I have some statistics here. So you see, gosh. Yeah. So you see, if I load in the pre-computed MEL spectrogram, it takes only 20 milliseconds to read a batch of tensor. And if I do the transformation on the fly, it takes 500, 600 to 100 milliseconds, depend on the, what does it depend? Okay, depends on the length of the subclip. So if my subclip is 8 seconds, it takes 600 milliseconds. So in this case, I think it's more than 10 times. So based on this speed up, I can run way more experiment with my GPU limit, and I can complete my experiment way faster. So I think based on that, I will simply just give up the augmentation that I do in audio space first. and then just use this pre-compute method, because at the end, I can always revert back to audio space and do the augmentation to train the final model. But having this pre-computed method can have it speed up doing experiment. Yeah, that's another thing. So finally, I'm trying to wrap up my code that I write in the messy notebook into modular code. Essentially, just write it as a more standardized modular code base and maintain that in the GitHub. Hopefully, I can maintain my code in the repository, so I can run it in both Kaggle and Colab. You know, if I can do this, I can just simply pull my Git repository from my account into the Kaggle and Colab, and then just import my module and run the experiment. In this way, so my code is more trackable. Because right now it's really hard to track. Right? It has a version control, but you know, when I look at the logbook, it's too long. Yeah, I think that's pretty much what I did. And next week I think I will keep doing the masking first. And also I want to complete the modularization and I think next week I have more time to try out the pseudo labeling again. Yep, that's my part.
Cool. Thanks. All right. I think nothing else. Then we'll call it, and we'll meet again next week, same time.
Thank you.
Sure.
Thanks, Alex. Thanks, you. See you. Bye.
See you guys.